All right, here we are, part three of beaches and coastal areas. And so in this segment, we're going to talk about sand movement on the beach and why, if you're swimming, say you laid out your beach blanket and you get in the water, and then 10 minutes later, you're 10 feet down the beach in the other direction. So, why does that happen essentially? And that has to do with the way that waves hit the shoreline and then refract or bend away. So, there's actually movement of sand that happens not perpendicular, but parallel to the shoreline as a result of the waves hitting kind of at a perpendicular angle. So when waves hit the shore, the waves are bent, and it causes the waves to move kind of parallel to the shoreline. And as a result of that, what you tend to see is changes in the shape of coastal features. So the waves can actually change the landscape pretty dramatically. So here's an example of what that looks like. And if you've been to California, you see a lot of these features. Also in the northwestern United States, where you have waters approaching the shoreline pretty straight on. And then when they hit, they tend to refract or bend, which concentrates all that energy into one area, generating some cool features like right here, you've got this headland, which is the same as this area here. And then you get some deposition on either side of that headland here, and you get little beachy berms. Right, so we see a lot of this landscape out west. All right. And then the sand that is eroded and then eventually deposited is carried along shore by those waves. So the waves will seldomly approach the shoreline straight on, but typically will actually hit at an angle and then are refracted. And as they're refracted, they're carrying that sediment along the beach in these currents that we call longshore currents. And so beaches can be characterized as something called like a river of sand, in that it's not just the water that is moving along shore, it's actually the water plus the sediment load that's moving along shore and eventually being deposited to create new landforms. So here we have an example of longshore transport. So the obviously the waves are hitting kind of at an angle here. I don't know if you can see it, but here are the waves. Let me use blue. So the waves are hitting here, 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 and then being bent or refracted, creating a current that is slowly moving water and sediment or rivers of sand along the shore this way, right? And so you can see that here. The waves are actually hitting at this angle and then bouncing back, and the current itself is being driven that way. And what it does is it causes there to be sediment carried down down beach, and you can see some of those sediment deposits right here along the berm. So that movement of water and sand can create rip tides or rip currents. You guys sometimes see beaches that have signs like beware of the rip tides, or beaches closed during severe storms where the wave energy is stronger and therefore the currents that result from the waves refracting off the beach are stronger. And this can cause obviously some dangerous currents that actually have caused people to flood. Anyway, drown, scary. Here's an example. Dangerous rip currents, right? So here you can see some of that energy from waves hitting at an angle, interfering with the incoming waves. So this is like, here's the longshore current, and then here's a rip current, creating a more turbulent situation there. So I'm going to stop with that. Actually, you know what, I'll keep going. All right. So some other landforms that we see in these coastal areas include cliffs and terraces, where waves are eroding the base of cliff faces along the coastline and creating like these bench-like surfaces. We tend to see these kind of wave-cut platforms and marine terraces in areas that have plate tectonic activity. We can also see other erosional features like sea arches and sea stacks, and these are cool. These are typically in areas that have active plate margins, like the northwestern United States. In Oregon and Washington, you see a lot of these erosional features where you have cliffs that are a little bit more resilient to erosion. And because you have stronger wave action eroding the landscape, you tend to get all energy kind of focused in one area, leading to the formation of these cool features. So here's an example of something you might see in Oregon or Washington or other areas where you have stronger currents and more resistant coastal cliff faces. Then you can also get depositional features, because whatever is eroding, that sediment is being carried somewhere or transported somewhere and then eventually deposited. So some of the depositional features that we see include spits, sandbars, peninsulas, or baymouth bars. So these are interesting little features. Here's an example of a baymouth bar in Massachusetts. This is Provincetown in Rhode Island. Actually, that's also Massachusetts, my bad. So this is an example of another spit here. And these are areas, again, where you have currents that are transporting and depositing sand offshore. So barrier islands, here's another example of where sediment is transported and deposited. So if you travel to North and South Carolina, you see a lot of these barrier islands. Also the Florida Keys and areas of the Gulf of Mexico. And they're pretty cool. A lot of people like to vacation there, but they're problematic in that because these are sediment deposits during severe storms and hurricanes, these areas tend to flood and becomes a little bit more problematic as a result of that. So here's an example of Cape Hatteras, which is off the shores of North Carolina. There's also Cape Lookout. So all of these areas here are an example of sandbars and spits and things that have been created by wave action on the eastern coast. Shorelines are constantly evolving. That makes sense because energy changes. So during the summer, you have more energy transferring through the atmosphere and then the surface of the water, creating waves that constantly modify and change coastal landforms. Whoops, sorry. Here's an example of that happening in an area where, waves might be hitting the shores again at an angle and then refracting back, creating a longshore current that then erodes the landscape and creates islands and arches and other features. And then slowly over time, those features might continue to erode, and you might get more depositional landforms, um, like these baymouth bars and spits and other sandy beach deposits that you see down here, right here and here. So again, constant state of change through time, because energy is constantly being transferred between the air and the water. There's two different types of coastal classifications. I'm not really focused on this in this unit. We have what are called emergent and submergent coastlines. Emergent are examples of areas where the beach has experienced uplift, typically because right now we don't have a drop in sea level, we have quite the opposite. So some examples of places where there are emergent coastlines would be the California coast, also Hudson Bay, Canada. So these are places where we see cliffs, we see terraces, we see wave cut kind of plateaus. Whereas submergent coastlines is just the opposite. The opposite of emerge is submerge. And so this would be an area that's experiencing a rise in sea level or land subsidence. So an example of where submergent coasts exist would be the East Coast. And we see a lot of estuaries, which are rivers that enter the ocean, so freshwater systems that enter saltwater oceans. And then we see highly irregular shorelines with spits and baymouth bars and all sorts of crazy features. So this is where the monks vacation every summer. We vacation really in Delaware, where, like right about here, where the Chesapeake and the Atlantic Ocean meet. And there's a lot of estuaries, which are river systems. They're awesome ecosystems. We see there's these baymouth bars, there's spits, there's headlands, there's all sorts of erosional and then depositional features in that area. All right, so speaking of East Coast, West Coast, very different topography, very different coastal landforms in each of these areas. The Atlantic and Gulf coasts typically have a lot of development, and development occurs even on the barrier islands. And because there's so much development here, obviously these areas of the East Coast and the Gulf of Mexico are subject to severe storms and hurricanes. So again, if you've been to the East Coast, you know that human impact is definitely a concern here, because so many people vacation there and have homes there, and yeah, it's just highly developed. The Pacific coasts are a little bit different in that Pacific coasts, their biggest problem is the fact that beaches are eroding rapidly. And due to this erosion, it's very difficult to protect the cliffs. Again, the topography here is much steeper. The waves are much bigger, and you tend to get more cliff faces that are compromised by changes in wave action. And you also get a lot of houses built on these cliffs. So you go to like Malibu and other places, and you have these beautiful multi-million-dollar mansions that are kind of teetering on the edge of sea cliffs. And obviously erosion and storm systems are really scary for those people, because those cliffs can become easily compromised. So protecting coastlines is an entire industry. There's coastal management and people that are hired to protect and preserve these coastal areas, mostly due to, I would say, development, but also in part due to the ecosystems they provide. So I'm going to stop here because the next part is really about human impact more than anything. And we're going to talk about that on Friday when we have our real world curriculum connection related to beaches. So I'm going to peace out for now. This is the third part in a 3-part series, and I will talk to you guys later this week.